What if the reason we can't solve quantum physics has nothing to do with intelligence, funding, computing power? What if the problem is that we're trying to answer a question inside of a framework that was not built to answer it? Think about how a computer works. You can have the most powerful software in the world, but if the operating system underneath it is outdated, there's a ceiling. You hit it eventually. It doesn't matter how good the code is. I think that's exactly what's happening in physics right now. And to understand why, you have to look at how physics has actually advanced, not just what it has discovered up to this point, but what changed every time it made a massive leap, right? Before Einstein, physics operated from a specific assumption. Space is space and time is time, two separate things. That was the foundation, the operating system from which physicists asked questions and built models. And it worked for a long time. It worked really well. But Einstein didn't just answer better questions inside that system. He looked at the system itself and said, I think you've got this wrong. Space and time aren't two separate things. They're one thing, space time, a fabric. And that changes everything. That upgrade wasn't just a new answer, it was a new field to answer questions from. And once physicists started operating from that new understanding, things that were previously impossible to explain started making sense. GPS satellites, gravitational waves, the bending of light around massive objects, all of it became answerable from within the new OS, right? Einstein's name isn't famous because he was the smartest person in the room. It's famous because he gave everyone a better room to think in. Now, here's where it gets interesting. Quantum mechanics is genuinely strange. Particles that exist in multiple states at once. Don't even get me fucking started on this bullshit. Entanglement, the observer effect, where the act of measuring something changes the outcome. It doesn't behave like anything in classical or relativistic physics. And the physics community has been trying to reconcile quantum mechanics with Einstein's framework for almost 100 years. String theory, loop quantum gravity, the many worlds interpretation, brilliant people, enormous effort, real progress in some ways, but no unified theory, no clean resolution. What if the reason for that is simpler than we think? What if quantum mechanics is pointing at something outside the field we're currently measuring it from? The observer effect, for instance, the fact that, you know, it's not even consciousness interacting with the system changes it. It's the act of measuring it. Um, but that's not a quirk to be explained away. That might be a signal that the observer is part of the equation in a way that space-time as a framework doesn't have the language to describe. Jiddu Krishnamurti wasn't a physicist, but was one of the clearest thinkers of the 20th century, spent decades pointing at something he called a state of being that is beyond time. Not outside of time in the sci-fi sense, but a mode of awareness that isn't organized by past and future. He wasn't making a physics claim, but it's interesting that the deepest anomalies in quantum physics keep pointing toward the same territory, toward something that doesn't fit neatly into a timeline, a location, or a fixed state. What if the next operating system for physics isn't about finding a better equation inside space-time, but about recognizing that consciousness or awareness itself is part of the field? That measurement isn't just a technical act, it's a participatory one. That the next Einstein won't be someone who solves the equations, they'll be someone who looks at what we're measuring from and says, I think we've got this wrong. Every major leap in physics has always followed the same pattern. Not more answers, but a better foundation. Newton gave us the first real OS. Einstein upgraded it. And quantum mechanics, for all its strangeness, might not be a problem to be solved inside Einstein's framework. It might be the friction that tells us it's time for another upgrade. So the question isn't who's smart enough to unify the theories, David Bohm. The question is who's willing to question the field they're trying to unify them in. That's what Einstein did, and I think, personally, that's what the next breakthrough will look like.